The discovery of a mysterious rock on Mars by NASA's Perseverance rover has sparked excitement in the scientific community, raising the possibility that the red planet may have once supported extraterrestrial life. The rock, adorned with dark-bordered tracks containing iron and phosphorus, resembles leopard spots found on Earth, which are typically produced by microorganisms. This has led to speculation about whether microbial life once thrived on Mars. Additionally, researchers have discovered a massive underground reservoir of liquid water, further increasing the chances of Mars being a life-friendly world. The rock in question, named Rover Falls, is located in the Jezero crater, a site that was once a vast lake billions of years ago. It features broad white sulfate veins surrounding a darker reddish material, rich in hematite. More intriguingly, it contains small, irregularly shaped spots encircled by black rings, which scientists believe may indicate chemical reactions used as an energy source by microbial organisms. While organic molecules are often associated with life, they can also form through geochemical processes, such as volcanic activity. The presence of the mineral olivine suggests the possibility that Rover Falls' composition could be the result of past volcanic activity rather than biological processes. However, Perseverance's remote sensing capabilities are limited, and the rock's true nature can only be determined once samples are brought back to Earth for further analysis. Meanwhile, seismic data from the Mars InSight mission has revealed the presence of a vast underground water reservoir, which could be large enough to cover the planet with an ocean 1 to 2 kilometers deep. Previously, scientists believed that Mars water had disappeared into space due to the lack of a magnetic field, but new research suggests that much of it may have seeped into the planet's crust instead. The porous nature of the Martian middle crust, filled with liquid water, raises the question of whether life could still exist in these underground reservoirs. Given that extreme life forms thrive in harsh environments on Earth, scientists see no reason why Mars' subsurface water couldn't support life as well. While the existence of Martian life remains unconfirmed, these discoveries have provided scientists with promising leads and new locations to explore. Future Mars missions are expected to play a crucial role in unraveling the mystery of whether life ever existed on the red planet. NASA and its international partners are developing plans to retrieve the samples collected by Perseverance, a process that could take years but promises groundbreaking discoveries. Once these samples are back on Earth, scientists will be able to conduct high-precision analyses using advanced laboratory instruments, potentially providing definitive evidence of past or even present microbial life. In addition to rock and soil samples, future missions could also focus on directly probing Mars' underground water reservoirs. Robotic landers equipped with drilling technology may be able to access these hidden reserves, searching for biosignatures or even living microorganisms. If confirmed, such a discovery would revolutionize our understanding of life's potential beyond Earth, proving that life can arise and endure in extreme environments. Moreover, the findings on Mars have profound implications for space exploration and our long-term aspirations of colonizing the planet. If liquid water is indeed present underground, it could be a vital resource for future human missions, providing drinking water and even hydrogen for fuel production. This would significantly reduce the need to transport water from Earth, making long-term habitation on Mars more feasible. At the same time, scientists are also exploring whether Mars' volcanic activity has completely ceased or if there are still active magma chambers beneath its surface. If volcanism continues in some form, it could affect the planet's potential habitability and provide insights into its geological evolution. Future seismological studies may confirm whether heat from Mars' interior could sustain liquid water pockets, further increasing the chances of microbial life existing today. Ultimately, The discoveries made by Perseverance and other Mars missions mark just the beginning of what could be one of humanity's greatest scientific breakthroughs. As technology advances and space agencies push the boundaries of exploration, we may one day answer the age-old question, are we alone in the universe? If the search for extraterrestrial life on Mars proves successful, it would redefine our place in the cosmos. The discovery of even the simplest microbial organisms beyond Earth would confirm that life is not unique to our planet and may be widespread throughout the universe. Such a revelation would raise profound scientific, philosophical, and even theological questions about the nature of life and the conditions necessary for its emergence. For now, the focus remains on gathering and analyzing as much data as possible. Perseverance continues its mission, systematically exploring the Jezero crater and collecting rock samples that could hold the key to Mars' ancient past. Scientists are particularly interested in examining whether Mars once had a habitable environment similar to early Earth, where life might have thrived before the planet underwent its drastic climate change. In addition, upcoming Mars missions, such as the European Space Agency's ExoMars rover and NASA's proposed Mars sample return mission, will further expand our knowledge. These missions aim to dig deeper, both literally and figuratively, into the planet's history, investigating its subsurface layers and analyzing the chemical signatures locked within its soil. The hope is that these efforts will provide more conclusive evidence regarding Mars' potential to support life. Beyond Mars, the implications of these discoveries extend to other celestial bodies in our solar system. If life once existed on Mars, could it also exist on Jupiter's moon Europa or Saturn's moon Enceladus, both of which are known to harbor subsurface oceans beneath their icy crusts? The search for extraterrestrial life is no longer limited to Mars alone. It is a quest that could eventually lead us to unexpected places throughout the cosmos. As humanity continues to push the boundaries of space exploration, the answers we seek may be closer than ever. With every new mission, every new sample, and every new discovery, we move one step closer to uncovering the truth about our place in the universe. Whether Mars still holds living organisms or only the fossilized remains of ancient life, one thing is certain. The red planet still has many secrets to reveal, and our journey of exploration has only just begun. As our technological capabilities grow, so does our ability to uncover Mars' deepest mysteries. The upcoming Mars Sample Return mission, a collaborative effort between NASA and the European Space Agency, aims to bring back rock and soil samples from the planet's surface for detailed analysis on Earth. This will allow scientists to use advanced laboratory techniques far beyond the capabilities of Perseverance's onboard instruments, potentially providing definitive proof of past or even present life. Meanwhile, researchers are also exploring the possibility of human exploration on Mars. Establishing a human presence on the red planet would revolutionize our understanding of its geology, climate, and potential habitability. Astronauts could conduct real-time experiments, explore regions beyond the reach of robotic rovers, and even drill deeper into the Martian crust in search of hidden life. Organizations like SpaceX and NASA have already begun developing technology aimed at making human settlement on Mars a reality within the coming decades. Beyond scientific discovery, the implications of finding life on Mars extend to questions about the origins of life itself. If microbial life once thrived on Mars and shares common characteristics with life on Earth, it could suggest that life originated from a common source and was transported between planets via meteorites, a concept known as panspermia. On the other hand, if Martian life is fundamentally different from life on Earth, it would indicate that life can arise independently in diverse environments, greatly increasing the likelihood of life existing elsewhere in the universe. As we await the return of Martian samples and future missions, The search for extraterrestrial life continues beyond Mars. Moons like Europa and Enceladus, with their vast subsurface oceans, remain prime candidates for exploration. The James Webb Space Telescope and upcoming interplanetary probes will further investigate exoplanets in distant star systems, analyzing their atmospheres for potential biosignatures. Ultimately, whether we find definitive evidence of life on Mars or not, the pursuit of this knowledge will drive humanity to explore further, innovate faster, and redefine our place in the cosmos. The discovery of extraterrestrial life, if it happens, would be one of the most profound milestones in human history, forever changing our understanding of what it means to be alive in this vast and mysterious universe.